Today we're going over exponential decay. The formula for the equation is the exact same. It is y equals a times b to the x power. Who can tell me what the a stands for? The starting amount. And b, what is the b? Growth or decay factor. Since we're doing decay today, it's the decay factor. Yesterday it was the growth factor, but it's both. It's the growth or decay factor. So for growth, yesterday, to get this number, you take 100% and you add your growth percent to it. Then you change it to a decimal. But for decay, instead of adding, we're going to subtract. So you take your 100% and subtract your decay percent. 100% as a decimal is 1. Then you subtract your percent changed as a decimal. And that's how you get that number. So for example, if I am decaying at 5%, I would do 1 minus 0.05. Because 5% as a decimal is 0.05. Does everybody understand? All right. So if you weren't here yesterday, you need to write these steps down. If you were here, you can write them down if you want to, but they're on your notes from yesterday. If you want to write a function from a table, your button called Stat in your calculator will do it. So you go to Stat, you go to Edit, and then you put in your numbers. Remember that L1 is X's and L2 is Y's. Then you go to Stat, Calc, and for exponential, you're going to choose option 0. Okay, so we're going to write, first we're going to tell whether the table represents an exponential function. If it does, you will see that it's being multiplied by the same number going up or down. If it does represent exponential function, we're going to write a rule. So everybody look at the first example. Do y'all see a pattern that something's being multiplied every single time? What are we multiplying by? If I multiply by a third, the number is going to get smaller. What's happening to the number? It's getting bigger. So how do I get from 1 to 3? Times 3. How do I get from 1/27 to 1/9? Times 3. So this whole table is being multiplied by 3. That is what an exponential function is. It rapidly grows or it rapidly decays. This is growth because it's getting bigger. All right, so if I want to write my function, I go to Stat, Edit, and I put those numbers in. Once I have the numbers in, I go to Stat, Calc. Now I'm going to say it again. Option 4 is only for what type of functions? Linear. Look at option 5. I know we haven't covered this yet, but you have a benchmark next week. So option 5 will give you what kind of function? A quadratic. So if you get a question and it gives you a table and it says which function represents this quadratic equation, then you go to option 5. Okay, but I want option 0, which is right under 9, for exponential. Hit enter, and it will give you the answer. Now, what is 0.3 repeating? So my equation is, and they tell you right here, you're going to write your equation y equals a times b with an exponent of x, where a is a third. So y equals 1/3 times b, which is 3, with an exponent of x. Good? Easy? All right. Look at the next one. Let's see if this table represents an exponential function. How would I get from 8 to 4 by multiplication? Get by multiplication. Times 1/2. Because multiplying by 1/2 is the same thing as dividing by 2. All right, how would I get from 4 to 1 with multiplication? Times 1/4. Is that the same thing? So this table does not show an exponential function. To be an exponential function, the growth factor has to be the same every time. So here, I was multiplying by 3 across the whole table. Here, I multiplied by 1/2 and then 1/4. That's not going to work. Make sense? All right, the next one, we're going to fill out a table and identify the domain and range. So if they give me the function, I don't need stat. I already have it. So where will I go? I'm going to go to y equals, and I'm going to go to second table to fill this table out. Okay, fill out your table. Did you notice every time I'm multiplying by 1/2? Yes? All right, let's look at the domain and range. Domain is the x, the range is the y's. Now, if you weren't here yesterday, go to the top of your paper. You can draw this if you were here, but if you weren't here, you really need to draw this. An exponential function on a graph will approach a line but never touch it. Who remembers from yesterday what that vocabulary word is called? Starts with an A. Asymptote. Okay. If it's growth, it's going to be going up, and if it's decay, it's going to be going down. So if I wanted to graph a decay function, it's going to look something like this. And right here, this is the asymptote. It is the line that it is approaching but never touches. It looks like it's touching it, but it's not. It will never touch it. Everybody good? All right, so let's go down. Now again, if I want to see the domain and range in my calculator, my windows probably need to be set to where I can see it, like -10, +10. So if I graph this function, it looks like this. It's going down. Like this. Is it touching the x-axis? No, and I know that because watch. When I get to y, it's never going to touch it. It just keeps getting to be a smaller fraction, and then it's so small that they turned it to scientific notation, but it's still never going to touch 0. Make sense? All right, so the domain, the x-axis, is it going to keep going forever and ever like this? Is it going to keep going forever and ever like this? That means the domain is all real numbers. But the range, is the line ever going to go down here? No. It's always going to be above 0. So y is greater than 0. All right, y'all try this one on your own. Fill out the table, identify the domain and range quickly. Check your answer with mine. Okay, how did we do? Easy? All right, turn the page. Now we're going to graph 3 functions and compare them. Yesterday we learned what a vertical stretch, a vertical shrink, and a reflection was. So we're going to take that knowledge of what we learned yesterday and we're going to try it again today. This is the parent function. This one, what did I add to it? A multiply by 3, and this one, what did I add to it? A multiply by -3. So we're going to take what we learned yesterday and expand our knowledge. So here we go. Let's go fill out our table for this function first. So all you got to do is go type in 1/4 to the x power. Everybody got it? Now we're going to go graph that on this graph. If -16 isn't there, then you obviously can't graph it. But here's -2, +16. So it'd be somewhere like way up here. -1, 4. Just know it's going to shoot rapidly up. 0, 1. So my graph's going to look something like this. Where is this? What is this called right here? It's approaching this line, but never what? That's called an asymptote. All right. Now let's go do, so that's this one. Now let's go do this one. Okay, now I'm going to go do the last one. Okay, let's compare them. This is the parent function. When I multiplied that parent function by 3, it took it and it stretched it up. Yes? So from y equals 1/4 to the x power to y equals 3 times 1/4 to the x power, adding this 3 in caused a vertical it vertically stretched it like this. Yes? All right. To go from this parent function and then adding a negative 3 in front, the 3 again caused a vertical stretch. And then it took it and flipped it across the what? X-axis. So that is a reflection across the x-axis. So if you add a number to the front that's greater than 1, it's going to vertically stretch it. If you add a negative in front of it, it's going to reflect it. Yes? Okay, flip the page. So this time, instead of adding a number greater than 1, they added a number smaller than 1, which is going to cause what? A vertical shrink or compression. So if you just want to copy down my table, you can. You don't have to go put it all in. And then go graph it. It doesn't have to be perfect. All right, so to go from the basic parent function, which was 1/4 to the x power, and add a 1/3 in front of it, because the number is less than 1, it caused a vertical shrink, or what you could call compression. It horizontally stretched it, pulled it that way, not vertically, right? And then again, if you put a negative sign in front of it, what's a negative going to do? Reflect it across the x-axis. Okay, flip to the back. Let's look at a real life question that can be used. So we know the exponential decay model, you already know it, is y equals a times b to the x power. Where to get this number, you're doing 1 minus the percent. All right, the number of acres of pine forest decreased in the western United States from the year 1963 to 2002 by 0.5% annually. There's your percent. What am I going to do to that percent? Change it to a decimal. How do you change a percent to the decimal? Move the decimal place 2 places to the left. So 1, 2. So I have 0.005. In 1963, that's the first year. Does everybody agree that's the starting year? In 1963, there were about 41 million acres of pine forest. So that's my starting amount. Now, I could go type out 41 million, or I could just put 41 and then include million in my answer. Okay? So I have 41, open parentheses. How am I going to get this number? 1 minus 0.005. Why am I subtracting? Because it's what? Decreasing. And then I need an exponent. Well, how many years are we talking about from 1963 to 2002? So 2002 minus 1963 is 39 years. That's your exponent. So your exponent is your years. How much pine forest was there in 2002? So at the end, so after 39 years, how much was there? We'll go type this in your calculator. So 41, open parentheses, 1 minus 0.005, close parentheses, to the 39th power. And there's your answer. There was about 33.7. And what do I have to include in my answer? Million. If this trend continues, how much pine forest would be left today? Well, what year are we in? We're in 2023. So what's 2023 minus 1963? 60 years. So I can take that same equation, but instead of to the 39th power, I change it to the 60th power. If the trend continues, I would have about 30.35 million left today, if the trend continues. Okay, put your name. On 1 and 2, it says, tell whether the table represents an exponential function. I'm telling y'all this. One of them's yes, one of them's no. If it does, write a rule. And then if it does, you'll use stat. Okay, 3 through 11, you're going to graph the function, which is super easy because you're going to use your y equals button, and then second table. But then you must also identify the domain and range. Guys, all the domains are all real numbers. I just gave y'all every answer. And the range will either be greater than 0 or less than 0. If it's above 0, it's greater. If it's below 0, it's less. It's super easy. Okay? Flip to the back. You're going to do 12 through 18. So you are going to do 18. $18 is not multiple choice. Do not circle one. It wants you to find the value for 1 year, find the value for 3 years, find the value for 5 years. So you just change the exponent to those years. Make sense? All right, for 12 through 14, it wants you to graph this function and that function and compare them. So how many are you graphing? 2, and then you compare them. On 15 through 17, you're going to say whether it shows growth or decay. So it's super easy. Then write a rule. You're going to use stat for that. So how do you know if it's showing growth or decay? If it's going down from left to right, it's what? Is this going down? So what is that? Decay. If it's going up from left to right, it's growing. From left to right, move your finger on the line. If it's going down from left to right, it's decay. If it's going up from left to right, it's growth. Make sense? And then you write a rule, just use stat. All right, so you have to do 18, and that's the only word problem you have to do. Get busy.